Alrighty, I want to do a little video here going over transformers. I recently was able to salvage this casting machine the other day, and it had this Variac transformer in it, and I had a friend of mine say that they were kind of impressed that I was able to understand how these transformers worked, and I was able to salvage and fix them. So I thought I would make a video going over how basic transformers work. So we'll start with this one. This one is a voltage changing transformer. It takes AC voltage and it changes it into a different voltage of AC, and it sacrifices its amps to do so. And what this is there's all these metal plates here, and each one of these metal plates, when you send an electric current through this coil or one of these coils, it makes each one of these plates produce a magnetic field in response to the current passing. It's just how an electric magnet works. When you have a coil of wire around an iron core and you connect that to a battery, it makes a magnetic field. The metal magnetizes. And by having multiple plates here, you create many magnetic fields all at once. And as the magnetic fields expand, when you send a current through this coil, the expansion of the magnetic field creates another current in this coil, but only while the magnetic field is expanding. When it's done expanding, then the current stops in the secondary coil. If the magnetic field collapses, or if the electricity gets turned off in the original primary coil and the magnetic fields collapse, then it pushes the electric current in the opposite direction in the secondary coil. So if you put an alternating current into this coil, you get an alternating current out of that coil just from these pieces of metal making an expanding and collapsing magnetic field. Okay, so that's how a dual coil transformer works. Now, some transformers don't have two coils, they only have one coil, like this one. This is a step up, step down transformer from 120 volts AC to 240 volts AC, or from 240 volts AC down to 120 volts AC. And it's a single coil of wire, but this wire is made up of two wires that are wound together as one coil, and it has three connections to it. It has one end of the coil, it has another end of the coil, and it has a middle tap wire right here. This is connected to the very center of the coil as it's wound through all the metal plates here. And to get 240 from 120, you connect one line to one end and you connect the other line to the middle tap, and then out of this end and this end you get 240. Now if you put this end into 110 or 120 and this into another leg of 120, then you get 240 total. But then if you connect a wire to one of the ends and the middle tap, you get 120. And that's taking 240 and stepping it down to 120. So you can take 120, connect it here, get 240 out of these two, or you can connect 240 to these two and get 120 out of these two or these two. That's how the step up, step down transformer works. It's just one coil with two ends and a middle tap. Now there's another design for a transformer that's called a Variac transformer, or an auto transformer. And instead of the plates being in a square frame like this, the plates are in a circle like this, making a toroid. And they wrap the wire around the toroid until it's all the way wrapped around like this. This is one end, this is the other end, and throughout the coils, like over here, you have another connection here. And the way this works is you have this end and this end connected to the outlet, plugged into the outlet, But you have another wire that's connected to this brush right here that slides along the tops of the coils where the wire has been sanded down to expose the bare copper. That allows a wire to be connected to the circuit at any point along each one of these coils. And if you have a wire going from this brush to an outlet and one end of the 120 outlet to an output outlet, then by moving the brush along the surface of these coils, you're able to control how much voltage comes out this line and the brush that connects to these wires that connect a voltage circuit. So if you have one end connected here and the other end is connected here at this point of the coil, then you have this many extra coils to go past the 120 volts, and you can actually pump this voltage up to 150 volts using these extra coils if you connect the other end here instead of here. And that's how the Variac transformer works, or the auto transformer. I can demonstrate how it works with this setup I have here. This is the Variac that I salvaged out of this casting machine. I took it out and I rewired it, fixed it, because it was not wired properly and it did not have an outlet, or just all it had was all these wires just tied together, and somebody obviously didn't know how to wire it, so they just wanted to throw it away, and I rescued it. What I did is I have the Variac, like I said, there's one end here and the other end is connected over here, and those are connected to this 120 outlet. Now the output that's connected to the brush and to this end that's connected over here on this side is coming to this outlet right here that's connected to this rectifier right here. This is a AC to DC rectifier, and what I'm going to do is I'm going to connect the drive motor of this generator right here that requires 125 volts of DC in order to operate. And what we're going to be doing is we're going to be taking the 120 AC line and we're going to send the AC through the rectifier, making DC 120 volts. Actually, we're going to take it up to 150 volts DC through the rectifier to run the drive motor that's going to turn the generator. Alright, so I got the rectifier hooked up to the two wires that run the drive motor, but there's also two extra wires that connect the shunt coils of the generator for the output, the DC output of the generator. I got one connected here and the other one is not connected yet because we're going to get this moving first before we engage the output. So we turn this on here. We have our little indicator light that came on, so we know we have power. We got to make sure that the handle here is in the on position for the lawnmower motor rectifier. So we gotta prop this handle open like this. Alright, so now that's stuck in its on position. Now we can use the Variac to control the drive motor. So here we go. Turn this up. So that's full 150 volts. That's being pushed through the rectifier to make the generator spin. Now we have this rotary transformer. It's connected to the output of the generator, And if we energize the shunt coils, that turns on the rotary converter from the generator's output. And that's how the Variac transformer works. You can control AC voltage, which controls the speed of the motor, through the DC rectifier. So I can turn it up all the way like this. And if I keep this going, let's see if I can keep it going here. I have to clamp it with something. Well, anyway, that's how you can make old school technology, save it, rebuild it, and make it do work once again. This generator is from the early 1900s. This Variac is probably from 1950s, 40s maybe. This is very old technology. It's older than my parents. It's probably a little bit older than my grandparents, but they all still work. And the reason they work is because I rescued them and I rewired them correctly. So this is your basic lesson on step up, step down transformers, voltage transformers for AC, voltage Variac auto transformers, and DC or AC to DC rectifying ability transformer. Okay, so thank you for watching. Hopefully this taught you something about transformers.